Hello all, welcome to Chendu's TechNet. So today, so we will discuss what is lease timeout, right? So you might have faced in interview. It is a popular interview question, right? So they might ask you what is lease timeout and how that works, right? So you need to understand uh, the background and lease mechanism to give a proper answer or explain in a better way. So what is a lease timeout? Right. So, but before we jump into the lease timeout, whatever we have, so let's understand few, so background or basic concepts of the Windows cluster part, so that you will understand lease mechanism and lease timeout. Right. So let's, so take one example, like, so we have a always on availability group, right? So we have an always on availability group. So why we need a Windows cluster to have an always on availability group, right? So it's a mandate, right? So HDR, to have a HDR solution, we need Windows cluster, right? Though you install SQL Server as a standalone, so you need to have a Windows failover cluster to have a SQL HADR solution of your for your databases, right? Why is that? Let's understand why we need a Windows cluster. So how actually that works, right? For example, this is a Windows cluster you can consider. So you have a Windows cluster, right? So clustering is nothing but a collection of nodes or servers, right? So you have a node A, node B, right? So you have two nodes. Let's take a small example that you have a Windows cluster with two nodes. Now, if you install SQL Server, install SQL standalone, right? So you install a SQL Server standalone instance. The same thing here. We call instance 1, instance 2. Right? These two are standalone instances. You don't have a SQL failover cluster. So that is a different concept. I will explain that later. But if you have a SQL failover cluster, it makes sense to have a Windows failover cluster because, so SQL cluster and Windows cluster, whatever it is. So it is a clustered instance. But here it is a standalone instance, right? Why we need a Windows cluster for a standalone instances? Right. First thing to remember, so either it is a SQL failover cluster or always on Windows cluster. We need Windows cluster for automatic failover. Remember, so we need Windows cluster to support only automatic failover, right? So that is the reason starting from 2017, so we have something called clusterless availability group, whereas automatic failover is not supported. So only manual failover is supported in the clusterless availability group, which was introduced in 2017, right? That I will so discuss in a separate video, how to configure and what is the uses of so clusterless availability group and all. For now, understand this concept, right? So Windows cluster is for automatic failover. How automatic failover happens, right? So automatic failover, why we need Windows cluster to fail over the availability group, which is hosted on the SQL Server, right? Why we need Windows cluster? Let's understand this concept. Now, so you have a SQL Server, right? So let's talk, I am talking only the insta A. Automatic failover is happened from between A to B, right? Automatic failover happens from A to, sorry, this should be B. Yeah. Let's say A is your primary server, insta 1, right? So this is your primary server. When automatic failure happens, so when automatic failure happens, if there is an issue at instance 1 that is on your primary, then only automatic failure happens to secondary. This is your secondary, that is your insta 2. Automatic failover, right? So if there is any issues at this instance 1, then only automatic failure happens to insta 2, right? So now how this automatic failure works and how event failure happens, right? So let's understand the concept. So we have a SQL Server installed here, insta 1. So this is your primary. So as soon as you install SQL Server, so you let's say for example you install the SQL Server and you have configured an availability group, configured AC in the SQL Server. So as soon as you configure an availability group, it is actually hosted on the Windows cluster. Actually hosted on the Windows cluster, right? So it is availability group. If you configure, it will be hosted. So hosted is nothing but availability group will not host. It is just an interface where you can see an availability group at the fellow cluster manager. If you go here, close it. So I'm just taking you to the cluster, right? So if you see here, role, and this is the availability group. So don't worry about, so whatever state it is, for now, understand that this is just a interface where you can see that availability group from the fellow cluster manager. That's it. So it is not actually, so some logic or code which is showing here. So it is actually a fellow cluster manager is like your SSMS, right? Interface where you can see these resources here. Now, what happens is, right? So whenever you have an availability group configured, it has its own DLL, right? So DLL called dynamic link library. So it is kind of logic, or you can consider that. So DLL is a code where you can use for your program, right? So let's say for example you have created an availability group. So how you created an availability group in backend? So the availability group built using some kind of code, right? Either C++ or Java or Python, whatever code that SQL Server developed, right? For your information, SQL Server developed using the C++ code, right? So that DLL, either it could be a .NET DLL. So .NET and .NET DLL are integrated with the SQL Server for your information. Like for example, SSMS is using the .NET framework, right? So those are different stories. But if you use a DLL, and DLL is a kind of so reusable code of your application. SQL Server is one of the application, right? So this always on has this DLL, right? So this is what we call it as HADR, resource DLL, high availability disaster recovery resource DLL. What is that resource? Is your availability group, right? So this resource DLL hosted on this resource DLL is hosted on something called rhs.exe. So rhs.exe is a Windows executable where it hosts the resource DLL, R resource DLL. This is a SQL Server SQL Server DLL where it hosts on rhs.exe. right? So RHS.exe is a resource hosting subsystem. So what is that actually? So whatever resources we are hosting on the Windows cluster, it will be hosted in this exe. So it is kind of container where it hosts the resources. So in our case, always on is our SQL resource. We are hosting on the Windows cluster. So where we are hosting? So we are hosting on rhs.exe, resource hosting subsystem. So whenever you create an availability group, a rhs.exe will be created. I mean, rhs.exe will be created, or it already exists, or it will be created, and it will be hosting your resource DLL. So you created another availability group, another rhs.exe will be created, and it hosts this resource DLL. Okay. So for example, you have an availability group and you have a listener, you have an IP address, right? So you can host all these three into a single rhs.exe. Okay. So what I'm talking, so you have a standalone SQL instance. So you have a Windows cluster installed, and in the Windows cluster, you have something called rhs.exe. rhs.exe is a Windows so resource host subsystem. That is a Windows component, right? Whatever resources we configured on the cluster, right? So it can be a SQL server, it can be MSDTC, it can be any storage, it can be any resource we are hosting on the Windows cluster will be hosted in the rhs.exe, right? So it will be hosted in the rhs.exe. Now, why is that important, and why we need even bother about rhs.exe and whatever it is hosting, right? Now, this HADR resource.dll is your SQL high availability resource DLL, right? So what is your resource? Your always on availability group is your resource. Now, what will happen? This HADR resource DLL and SQL server is keep on talking. I mean, keep on talking as in like these will be in communicate with each other and checks the health of each other, right? For example, HADR resource DLL talk to your SQL server instance and check whether SQL is responding or not. At the same time, HADR resource DLL also SQL server also will validate HADR resource DLL is communicating on time or not. For example, let's say consider a alarm. So there is a every 10 second you should respond, right? So every 10 second this should contact here and validate whether SQL server is online or not. That also, this SQL also checks whether I am receiving an update from the HADR resource DLL or not, whether I am receiving a ping. It is kind of ping. So this will ping to SQL server, checks whether SQL server is online or not. At the same time, SQL server wait for this ping from the HADR whatever DLL that we have, right? So whether this communication is happening or not, right? So this communication is called as heartbeat, right? So this communication between your DLL, this is your as in like whatever resource which are hosting in the SQL hosting in the on the Windows cluster, this DLL and this SQL instance are communicating with each other or not. It validates whether the communication is happen between this DLL and the SQL server or not, right? So if it is online, if it is available, whatever reason, so these two are communicating, right? Then there is no issue. For some reason, whatever reason, some reason this is not responding. So this is trying to, talk to instance one, but instance one is not responding. Whatever reason, like instance one is not responding. right? So could be service stopped or could be whatever reason that we will talk later when we talk about the lease timeout, right? So this instance one is not even responding to HADR resource DLL ping, right? Now, then what will happen? HADR resource DLL inform this information to the RHS.exe, right? So HADR, it will check like sometime it checks whether SQL is responding or not, right? So it checks whether SQL is responding or not. If SQL is not responding within some intervals, within some few checks, then HADR resource DLL will inform the same to RHS.exe stating that I'm trying to contact instance one, but instance one is not responding. I tried twice, thrice, but it is not responding. Then what will happen? RHS.exe. So as soon as RHS, it informs, it tells that RHS.exe, then RHS.exe actually triggers the failover of your availability group, right? So in more on like RHS.exe, so there is a event, we call it as RHS.exe. It checks. So normally what happens when HDR resource DLL inform that information to RHS.exe, so it checks whether the value is 0 or 1, right? So it is background check. It checks whether it is 0 or 1, right? So it's a 0 or 1. If it is 0, the response is not happen, right? So if it is 0, the response is not happen. As soon as it sets the value to 0, this Windows cluster will trigger a failover of your availability group, right? So it's a RHS.exe which takes care of the failover of your availability group based on the information it receives from the heartbeat check, right? So in a high level, again I will explain. Yeah, this is your SQL Server. This is your Windows cluster, Windows Server failover cluster. This is your RHS.exe, whereas we host our resource here, HADR This is your resource DLL, right? So we have a Windows cluster. Since we have a Windows cluster, we will have that resource hosting subsystem, whereas DLL, see here HADR resource DLL. Why HADR resource DLL? So we call HADR for always on availability group, right? If it is a SQL failover cluster, so you will have another SQL cluster resource DLL, something SQL cluster resource DLL, whatever resource DLL we use for cluster, so that will be SQL plus resource DLL, right? So then the communication happens between HADR resource DLL to the SQL server, right? So SQL server, so within the same node again, right? So this is just a Windows cluster piece, but all are on the same node. So all are in the same node, right? All are in the same node. So these two are in the same node, right? So everything like these two, as in like the Windows cluster and SQL server, everything is on the same node. So it is not a different node. It is just a Windows cluster we have, and SQL server you can consider in another way. Like I mean, so this is a Windows cluster, and this is a SQL server installed on Windows cluster, right? So SQL server installed on this node and Windows cluster we have, and SQL is not hosted on the Windows cluster, right? Only the availability group is hosted on the Windows cluster. That is the reason we call HADR resource DLL is hosted on the RHS.exe. HADR resource.dll communicates to the SQL server, right? So how it communicates to the SQL server is something called as named pipes, right? So we know the so named pipe concept, right? So named pipe is a it is not named pipe, it is a shared memory. Shared memory, right? So why shared memory came into the picture? So it's a kind of protocols, right? Like that we have protocols. Shared memory is whenever you install a client and application within the same server, so the communication happens, right? The same way the Windows cluster and SQL server on the same computer, and your resource DLL also on the same computer, everything is on the same computer. So HADR resource DLL connects to SQL Server using the shared memory protocol and checks whether SQL Server is online or not. That's it. So it checks whether SQL Server is responding to my request or not, my ping or not. Right. That's it. So it will not do anything else. It checks whether SQL service is responding or not. So as soon as SQL is responding, so as soon as SQL is acknowledging for the response, it is okay. So if SQL is acknowledging, then it is okay. No issues. If SQL is not responding, then the HADR. So it checks like it is not one time check. Like for example, it is trying to reach SQL server. SQL is not responded. No, it will not immediately inform to the RHS.exe. The same way it checks around 1 or 2 times or 3 times, whatever it is. It checks every frequent intervals and checks whether SQL is responding or not. If it is not responding, then HADR resource.dll will inform to the RHS.exe stating that SQL is not alive. SQL is not responding, right? I told you SQL is not alive, right? So this is the old concept that we had in before Windows 2012. That is looks alive concept. So we will talk that. Right? So SQL, it tells whether SQL is responding. No, SQL is not responding within the like intervals, right? So I tried communicating, contacting SQL Server certain times, it is not responding. Then this RHS.exe sets that event as 0, right? So as soon as this set to 0, then Windows cluster detects that event, right? So as soon as RHS.exe sets that value to 0, RHS.exe doesn't know anything, right? RHS.exe only works in a binary values, like it is either 0 or 1. If it is 0, everything fine. If it is 1, if it is 0, there is an issue. If it is 1, everything is fine, right? So so sets the value to 0. As soon as it sets the value to 0, Windows Server failover cluster triggers the failover from this node to another node. Node B, right? Understand the concept? That is the reason we need failover cluster to be installed, right? So if you don't have a failover cluster installed, then you will not have a RHS.exe installed. So if you don't have a RHS.exe available, then your HDR resource.dll will not be hosted anywhere, right? It is just an isolated, so to the SQL server. There is no automatic failover happens. That is the reason in Windows clusterless availability group, we don't have a automatic failover. let me show you that RHS.exe here, right? I have two availability groups with respect to whether the state is online or not. And if you see, I don't have, one sec, I'm just clicked on resources. It is taking time. That's okay. Okay, let me take to task manager, right? So if you go to details, just go here, right? You see here, rhs.exe. These two rhs.exes that we have. Now it is loading, right? So you have two availability groups on this Windows cluster, each availability group hosted on individual rhs.exes within the same cluster, right? So likewise, you can have n number of window rhs.exe based on the configuration. For example, it is too slow. So this is clueadmin.exe. So is the one we use to open that Windows cluster. Is a shortcut, or you can just type failure cluster manager, it will open. Right. So let me say this. Okay. So let me close this. Open cluster role. And for example, if you go here, go to the properties. Yeah, I just click the properties. It is taking time. Right. Some reason it is taking time. Okay, so that is what I just wanted to show you, like rhs.exe will be created, and this rhs.exe, so we have the resource DLL. Let me show you that. So resource DLL you cannot see from the task manager or from the Velo cluster manager. So let me show you that the resource DLL what we have. Cluster, right? So if you open that registry key, so whereas you have that local machine and cluster, because this is a cluster node. Checkpoint resources. Okay, so resources we have test AZ, right? Test AZ, you have what role? Okay, sorry. Right. So we have test AZ, right? So let's see this. This is a test AZ, right? So if you expand this, parameters, you should have that. Okay. Microsoft SQL Server Network. Yeah, so this is what I was talking. SQL Server availability group, you have something called DLL name as HADR resource.dll, right? So this is for availability group. Likewise, if you have any failure cluster instance, you will have that SQL class resource SQL CLU, whatever, like SQL resource.dll, whatever it is, it will be there. right? So for availability group, this is the resource.dll that we have. Now, let's see, go to the properties. Advanced policies, run this resource in a separate resource monitor, right? So you have an option. By default, every availability group is hosted on one availability group. For example, you want to host this particular resource, right? This is the role, this is the resource. If you want to just host this resource itself in a separate resource monitor, now how many are there? Two are there, right? Let's see. If you just use this as a separate resource monitor, let's close this and open a task manager. You should see three as per the configuration. Let's see here. Three that you notice here, right? Let's see. Let me try to right. So we see three resource DLLs, right? RHS.exe. Likewise, you can spawn, you can configure each resource into a different monitor. So what is the benefit out of it, right? So why we need a different monitor? For example, let's say you have a IP address, you have a network name added here, right? If you use that separate resource monitor, in case if any of the resource is failed, right? So if you have a different RHS.exe, if any of the resource failed, it will be failed for only for that particular resource, right? For example, leave it. I don't want this particular resource to be hosted on a different RHS.exe. For example, if we host these two availability groups on the same RHS.exe, let's consider what will happen. Just assume if one of the availability group is failed. If one of the availability group is failed, then both will trigger a failover, which I don't want, right? If both will trigger failover, then what is the point of having two availability groups, right? Two is for one particular application, one is for one particular application, and this is for another application. So why we need two availability groups in that case, right? So we should not let one, so trigger failover of the other one, right? That is the reason we always have a dedicated RHS.exe for each availability group. Okay, good. So this is how the Windows cluster triggers the failover, right? So this is same concept that we have looks alive. We have two concepts called looks alive and is alive. So what is looks alive and is alive, right? So the same concept for looks alive, whatever we discussed. So it's a general scenario that we have, right? So what is the looks alive concept? Okay, let me expand this. Right. So what is looks alive? The same concept, same mechanism works. So you have a Windows cluster again. So looks alive within the same server. So anything happens, the checks, validates, heartbeat, everything within the same node, right? So this is the within the same node, right? This is one node. This is another node, right? So everything happens within the same node. So I'm just dividing this for the sake of simplicity, right? So everything happens in the same node. This one, this check looks alive. So how looks alive works? So looks alive, whatever concept that we discussed, the same thing, right? So looks alive. So again, the same rhs.exe. So which has that resource.dll, hadr right? So here it is Windows Server Fellow cluster. This is yours. Insta, yeah, Insta1 SQL Server, right? So it opens the same communication, shared memory, whatever communication it opens, it connects to the SQL Server, and what it happens, looks alive, it connects to the same server with service manager, right? Service manager on the same computer. You have something called service manager. Service manager, in simple term, we call it as a services.msc. You can just consider that server manager, service manager, whatever it is a simple words. You can consider services.msc. So rhs.exe, it connects to the service manager and checks whether SQL service is online or not. Just as simple as that. It checks whether SQL service is online or not, right? So my bad. So it is not open a connection to the SQL server with the shared memory. Looks alive, right? So looks alive. So what happens? It is a Windows, so component which connects to the service manager and validate whether the SQL service is online or not. That's it. So if the SQL service is not online, this consider that lease is looks alive check is failed, right? It checks every 5 seconds. So only one time. So first, every 5 seconds, it validates whether the service is online or not. If the service is not online, and another point is, it is not a HADR resource.dll, it is a any other SQL cluster resource DLL. SQL plus resource DLL. It is a SQL cluster resource because looks alive concept is for like in SQL Server side at least. So it was before Windows Cluster 2012 or SQL Server 2012. We call it as a looks alive check, right? So this service manager responds that the SQL service is not online. If SQL service is online, we are good. If SQL service is not online, so return back to the resource DLL stating that service is offline. Then it informs the same to rhs.exe, and rhs.exe take care of the failover. I mean, rhs.exe sets an event as 0 to Windows cluster, and Windows cluster trigger a failover of the availability group. That happens. What will happen? Again, I am just keep on talking about availability group, but it is Windows cluster component. It fail over the resource. You can consider that way. But after 5 seconds, if this check is failed, looks alive check is failed, there is something called is alive check. So is alive, what happens? It checks every 60 seconds. That is every 1 minute. Right? So it checks every 60 seconds, then validates whether my instance is able to open a connection or not. So how it checks? It opens a connection to the SQL server. It opens a connection to the SQL server, right? So then it executes a command called select edit server name, right? So it executes select edit server name to validate whether it is actually getting the response from the server or not, right? So if it gets the response from the server, then it considered as lease is alive. I mean, is alive check is success. If not, then is alive check failed, then a failover will be triggered by the RHS, I mean, Windows cluster. This is how looks alive and is alive check happens, right? Looks alive every 5 seconds and is alive check every 60 seconds. It triggers, it checks whether SQL service is responding for the query. That is called select edit server name. Now, starting from SQL Server 2012, right? We to so have a more rigorous checks, we introduce two detailed checks. That is called a lease timeout check. Lease timeout and health check timeout, right? So lease timeout and health check timeout, right? I will cover this in a separate video as I need to discuss a detail about the lease timeout and health check timeout, right? Keep watching. I will post these videos together so that you will have a better understanding. Thank you. Have a nice day. Bye-bye.